Q6704. When operating a gyroplane in conditions favorable to carburetor icing, the carburetor heat control should be A. Adjusted so the carburetor air temperature gauge indicates in the green arc. B. On when practicing power-off maneuvers such as auto rotations, but off at all other times. C. Off during takeoffs, approaches, and landings, other times, adjusted to keep carburetor air temperature in the green arc. The correct answer is A. When operating a gyroplane in conditions favorable to carburetor icing, the carburetor heat control should be adjusted so that the carburetor air temperature gauge indicates in the green arc. Carburetor icing can occur when the temperature and humidity conditions are conducive to ice formation in the carburetor. Ice accumulation in the carburetor can disrupt the proper fuel-air mixture, leading to engine power loss or even engine failure. To prevent or remove carburetor ice, carburetor heat is used. The most appropriate action to take is to adjust the carburetor heat control so that the carburetor air temperature gauge shows a reading within the green arc. This ensures that the incoming air to the carburetor is warm enough to prevent or melt any ice formation. By keeping the carburetor air temperature within the green arc, the pilot ensures that the carburetor is operating in a safe temperature range and that any ice present in the carburetor is eliminated. It's important to note that the other options provided in the question are incorrect. They either suggest incorrect practices or fail to address the need to adjust the carburetor heat control based on the carburetor air temperature gauge. The correct course of action is to monitor the gauge and make adjustments to the carburetor heat control as necessary to maintain a temperature reading within the green arc. 6831-1. If all other factors remain the same, an increase in relative humidity will A. Decrease the hovering ceiling because the air is less dense. B. Increase the hovering ceiling because the air is denser. C. Decrease the hovering ceiling because the air is denser. The correct answer is A. If all other factors remain the same, an increase in relative humidity will decrease the hovering ceiling because the air is less dense. Relative humidity is a measure of the amount of moisture present in the air compared to the maximum amount of moisture the air can hold at a given temperature. As the relative humidity increases, the air becomes more saturated with water vapor. Water vapor is less dense than dry air, which means that as the humidity increases, the overall density of the air decreases. In the context of a hovering ceiling, which refers to the maximum altitude at which a helicopter can maintain a hover, the density of the air plays a crucial role. As the air becomes less dense due to increased humidity, it provides less lift for the helicopter's rotor blades. This reduction in lift makes it more challenging for the helicopter to maintain a hover, resulting in a lower hovering ceiling. Therefore, an increase in relative humidity will decrease the hovering ceiling because the air becomes less dense, reducing the lift available to the helicopter. 6831-2. Performance of a helicopter can be determined by A. The highest altitude that can be maintained in a hover following liftoff. B. Knowing the density altitude, gross weight, and surface wind. C. The formula pi times the rotor diameter divided by the blade area. The correct answer is B. The performance of a helicopter can be determined by knowing the density altitude, gross weight, and surface wind. Density altitude is a measure of the density of the air, which is affected by factors such as temperature, pressure, and humidity. It is different from the actual altitude and provides a more accurate representation of the air's density and its impact on the helicopter's performance. As density altitude increases, the air becomes less dense, which can affect the helicopter's lift and engine performance. Gross weight refers to the total weight of the helicopter, including the aircraft itself, fuel, passengers, cargo, and any other load on board. The gross weight directly influences the helicopter's performance, including its ability to climb, maneuver, and operate under various conditions. Surface wind is the wind speed and direction at the helicopter's current location near the ground. The surface wind affects the helicopter's takeoff, landing, and maneuvering capabilities. Wind speed and direction have a significant impact on the helicopter's ground speed, ground handling, and the performance of its rotor system. By knowing the density, altitude, gross weight, and surface wind, a pilot or operator can make performance calculations and determine the helicopter's capabilities under specific conditions. These factors are essential for assessing the helicopter's climb rate, maximum altitude, payload capacity, range, and other performance parameters. Therefore, correct answer as it correctly identifies the key factors, namely density, altitude, gross weight, and surface wind, that play a crucial role in determining the performance of a helicopter. 6832. As altitude increases, the VNE of most helicopters? A. Increases. B. Decreases. C. Remains the same. The correct answer is B. As altitude increases, the VNE, velocity never exceed, of most helicopters decreases. The VNE is the maximum indicated airspeed at which a helicopter is structurally certified to operate safely without exceeding its design limitations. It is determined based on various factors, including the helicopter's structural strength, rotor blade limitations, and dynamic characteristics. At higher altitudes, the air density decreases. This decrease in air density affects the performance of the helicopter, particularly its rotor system. The rotor blades encounter less dense air, resulting in reduced lift and increased aerodynamic forces acting on the blades. These aerodynamic forces, such as compressibility effects, retreating blade stall, and increased drag, can limit the maximum safe operating speed of the helicopter. To ensure the safety of the helicopter and its occupants, the VNE is specified by the manufacturer and should not be exceeded. Pilots must be aware that as altitude increases, the VNE decreases to prevent the helicopter from encountering aerodynamic issues that could compromise its structural integrity or flight stability. Therefore, the correct answer as it accurately states that as altitude increases, the VNE of most helicopters decreases due to the effects of reduced air density and associated aerodynamic limitations. 6834. Which technique is recommended during hot weather operations in a helicopter? A. Descend rapidly during approaches. B. During takeoff, accelerate slowly into forward flight. C. During takeoff, accelerate quickly into forward flight. The correct answer is B. During hot weather operations in a helicopter, it is recommended to accelerate slowly into forward flight during takeoff. Hot weather conditions can have several effects on helicopter performance. High temperatures result in decreased air density, which reduces the lift generated by the rotor blades. This reduction in lift means that the helicopter requires a higher airspeed to achieve the necessary lift for takeoff. By accelerating slowly into forward flight during takeoff, the helicopter allows the rotor blades to gradually build up lift as the airspeed increases. This gradual acceleration gives the rotor system more time to generate sufficient lift, compensating for the reduced air density. Accelerating slowly into forward flight also provides additional benefits during hot weather operations. It allows the pilot to carefully monitor engine and transmission temperatures, ensuring that they stay within safe limits. It also allows for better control and stability during the initial stages of flight. On the other hand, accelerating quickly into forward flight can put excessive stress on the rotor system and may lead to inadequate lift during the critical takeoff phase. Descending rapidly during approaches is not a recommended technique for hot weather operations, as it can exacerbate the reduced lift conditions and compromise the safety and stability of the helicopter. Therefore, the correct technique recommended during hot weather operations in a helicopter is to accelerate slowly into forward flight during takeoff.